Hello and welcome to Business Calculus Derivatives of Logarithmic Functions. The inverse of an exponential function is a logarithmic function, which is given by this formula. If we have a base b that is greater than 0 and not equal to 1, we also have an equivalent exponential form of this logarithmic function given as so. We see that we have switched the domain and range for these two functions because we have switched the positions of the independent and dependent variables, y and x respectively. The process of making this switch is the reflection of the graph over the line y equals x. We see in red that we have the graph of the logarithmic function, and in blue the graph of the exponential function with y and x switched. Let's look at an example of our four-step process to find the derivative of the natural log of x. First, we calculate f of x plus h to get the natural log of x plus h. Then we calculate the difference, f of x plus h minus f of x, and get the natural log of x plus h minus the natural log of x. Using the property of logarithms that says that the difference of logarithms is equal to the logarithm of the quotient, we are going to combine these into one logarithmic expression, the natural log of x plus h divided by x. For part 3, we take our expression and divide it by h. Which we can think of as just multiplying by 1 over h. Now, we're going to perform a couple of algebraic steps here to prepare to take our limit. The first of which is rewriting the interior of our logarithm as 1 plus h divided by x. Okay. The next part is going to be multiplying our entire expression by a special form of 1, x divided by x. And using the property of logarithms that says that k times the natural log of x is equal to the natural log of x to the k power, we're going to take some of these terms out front here and pull them into the exponent of the argument of our logarithm. So we're going to have 1 divided by x on the outside, and on the inside we're going to have the natural log of 1 plus h divided by x to the x over h power. Alright. Lastly, we would like to take the limit as h goes to 0 of our expression. So we have the limit as h goes to 0 of our difference quotient. And so we have the limit as h goes to 0 of our previous expression. All right, what do we do now? I know that the limit does not depend on x, so I'm allowed to pull 1 over x to the front of my limit expression, treating it as a constant. That leaves me with the limit as h approaches 0 of 1 plus h divided by x to the x over h power. Now, as h goes to 0, if I set s equal to h over x, that will also go to 0. This allows me to make a substitution in my limit expression. So we're going to have 1 divided by x times the limit as s goes to 0 of the natural log of 1 plus s to the 1 over s power. Now, this should remind you of something. This guy right here is e if we take this limit. So what this gives me when I take the limit is 1 over x times the natural log of e. And the natural log of e is equal to 1. So I get that the limit of my expression is 1 over x. That is to say that the derivative of the natural logarithm of x is equal to 1 over x. Now that we know the derivative of the natural logarithm, let's find a relationship between the log base b and the natural logarithm, and then use that relationship to determine the derivative of the logarithm base b. We start off by writing the logarithm base b as a function of x. And then we recall that this expression is equivalent to the expression b to the y equals x. Next, what we do is take the natural logarithm of both sides of this equation, and using our properties of logarithms, we get that y times the natural log of b on the left-hand side equals the natural log of x. So if I divide both sides of the equation by the natural log of b, which I can because it's just a real number, I get y equals the natural log of x if I divide both sides of my equation by the natural log of b, which I can because it's just a real number, I get that y equals 1 over the natural log of b times the natural log of x. So this is our relationship between a logarithm base b and the natural logarithm ln x, because if I go back to my original statement, we see that these two expressions are equivalent because they both equal y. Now what I can do is write the derivative of both sides of this expression. So we get the derivative of the log base b of x equals the derivative of 1 over the natural log of b times the natural log of x. And the right-hand side is just 1 over the natural log of b, because that is a real number, times 1 over x, which is the derivative of the natural log. So this expression gives us the derivative of the logarithm base b. Assuming, of course, that x is positive. Stated as a theorem, it looks like this. For b greater than 0 and b not equal to 1, and for positive x, we have that the derivative of the natural log of x is equal to 1 over x, and the derivative of the logarithm base b of x is 1 over the natural log of b times 1 over x. Let's finish up with some examples. We would like to calculate the following derivatives. Here we have the derivative of the log base 3 of x plus 2, and that is equal to the natural log, 1 over the natural log of 3 times 1 over x. And then plus 0 because the derivative of a constant is 0. So we are left with 1 over the natural log of 3 times 1 over x. For example B, we need to rewrite our expression before we can differentiate it, but that's okay. Earlier, we used the property that if I have an exponent as part of the argument of my logarithm, I can bring it out front as a scalar multiple. So we're going to do that. Instead of trying to differentiate the log base 7 of x squared, we're going to differentiate 2 times the log base 7 of x, which we do know. So we're going to get 2 from our scalar multiple of 2 divided by the natural log of 7, because we have a base of 7, and then we're going to multiply that times 1 over x. What I would like for you to do now is to use our new knowledge of derivatives to find the derivative of f of x equals the logarithm base 4 of x to the 4th power, and g of x equals the natural log of 2 plus the natural log of x plus the natural log of x squared. Here are your choices for the values of those derivatives. And thank you very much for listening.